Hi and Assalamualaikum guys. So, in this video, we will explain about related rate of differentiation. This video is presented by Afikah binti Ghani, Mahira binti Khazan, and Nurhayatu Ridiani binti Razali. This video content of introduction, objective, problem statement, problem solution, strategies, and conclusion.
Introduction. Related rates problems involve two or more variables that change at the same time, possibly at different rates. If we know how two variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the equation with respect to time.
Objective. The objective is to find the rate of change of one quantity knowing the rate of change of another quantity. Problem statement. An ice cube in the shape of cylinder is melting at a constant rate of 2 cm cube per second. Find the rate of change of the surface area of the ice cube when the radius is 4 cm. Problem solution.
So, I will show the solution for this question. This question states that an ice cube in the shape of a cylinder is melting at a constant rate of 2 cm cube per second. Find the rate of change of the surface area of the ice cube when the radius is equal to 4 cm. So, in this question, we need to underline the word melting at a constant rate of 2 cm cube per second, rate of change of the surface area, and radius is equal to 4 cm. So, we can define dV over dt is equal to negative 2 cm cube per second because the question mentioned that melting at a constant rate of 2 cm cube per second. So, the question asks for dA over dt. So, to find dA over dt, we need to make the dV over dt is multiplied with dA over dV. So, we don't know dA over dV, then we need to find dA over dV. So, to find dA over dV, so we need to make the dA over dr multiplied with dr over dV. So, to find dA over dr, we can use the formula of area of the cylinder. So, the formula of the area of the cylinder is 2 pi r power of 2 plus 2 pi r multiplied with the h. So, this is the h of the cylinder, the head. So, the head is in this picture, you can see it. So, we solve the formula, then we got 4 pi r power of 2 plus 4 pi r. So, from this formula, we need to differentiate it to find dA over dr. So, after we differentiate it, we got dA over dr is equal to 8 pi r plus 4 pi. So, after that, we need to find dr over dV. So, before we find dr over dV, we need to find dV over dr. So, to find dV over dr, we can use the formula of the volume of the cylinder. So, the formula of the volume of the cylinder is equal to pi r power of 2 multiplied with the head. So, it's equal to pi r power of 3 plus 2 pi r power of 2. So, we differentiate it and we got dV over dr is equal to 3 pi r power of 2 plus 4 pi r. So, to find dr over dV, we can reverse it. So, dr over dV is equal to 1 per 3 pi r power of 2 plus 4 pi r. So, now we can find the dA over dV. So, dA over dV is equal to 8 pi r plus 4 pi multiply with 1 per 3 pi r power of 2 plus 4 pi r. Then we got the answer 8 pi r plus 4 pi per 3 pi r power of 2 plus 4 pi r. Then we get dA over dV. So now we can find dA over dt. So dA over dt is equal to -2 multiplied with 8 pi r plus 4 pi per 3 pi r power of 2 plus 4 pi r. So the final answer is -98 centimeter square per second. So we got the answer.
They have 5 strategies for solving related rates. For the first one, assign letters to all quantities that vary with time. Second, identify the rates of change that are known and the rate of change that is to be found. Third, find an equation, area, volume, Pythagoras theorem, trigonometry ratio that relates variables. Fourth, differentiate both sides with respect to time. And the last one, after differentiate both sides, substitute all known values and solve.
Lastly, conclusion. In short, to get the best and right final answer for this topic, students should apply all the 5 strategies that have been given. Last but not least, related rates are so important because there are so many real-world applications of it, like a snowball melting, a ladder falling, a balloon being blown up, and a stone creating a circular ripple in a lake. That's all from us. Thank you for watching this video.